GCE O-Level Mathematics, Lecture 5, Indices. Hello everyone, my name is Dennis. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out free lesson from me. The learning objectives of this lesson are to understand the concepts of indices, to understand the laws of indices, to simplify an expression involving indices, and lastly, to solve an equation involving indices. Indices. What is indices? An index or exponent is used to express how many times a number is multiplied by itself. Let's look at this example. 2 times 2 times 2. We can see that this number 2 is multiplied by itself for 3 times. Hence, we can write this as 2 to the power of 3, where the number 2 here is called the base or the body. The number 3 here is called the power or exponent. It is read as 2 to the power of 3, or it also can be read as 2 raised 3. Laws of indices. There are 8 laws of indices that you need to remember. Here are the 8 laws of indices. Law number 1. A to the power m times a to the power n equals a to the power m plus n. Law number 2. A to the power m divided by a to the power n equals a to the power m minus n. Law number 3. A to the power m times b to the power m equals bracket a times b close bracket to the power m. Law number 4. A to the power m divided by b to the power m equals a to the power m over b to the power m, or equals bracket a over b to the power m. These first 4 laws are sometimes called grouping laws. For the first and the second law, there is one thing in common, which is they have the same body. You can notice this a and this a, they are the same. If it is multiplied, then you can add the power together. Similarly, for second law, we have the same body a as well, and it is a division, so we can take the first power minus the second power. For law number 3 and law number 4, there is also one thing in common, which is they have the same power. Notice that for law number 3, here they have the power of m. So if it is multiplied, we can actually multiply the body first, then we go to the power m. For law number 4, it is similar, but now it's a division. The common power is m. So we can rewrite it as a to the power m over b to the power m, or we do the division first, then we go to the power m. Next, law number 5. Sometimes it is called bracket law, which is bracket a to the power m close bracket to the power n equals a to the power m times n. Notice that for this law, we want to remove the bracket. So for the power, we can multiply the power. Next, law number 6. A to the power of 0 equals to 1. So it means that it doesn't matter what's the value of the a. When go to the power of 0, it will always give us 1, unless if the a is equal to 0. So if 0 to the power of 0, there is no solution. So the next one, law number 7, is a negative power law, which is a to the power of negative m equals 1 over a to the power of m. Or if 1 over a to the power of negative m, it is equals to a to the power of m. So notice that this negative power law, if you want to make the power to be positive, then you have to change the position. For the first case here, this whole figure, it is at the numerator. So we want to make the power to be positive, so it will change the position for numerator to become the denominator. Similarly, here, this number is at the denominator. So we want to change the power to be positive, it will move up to become numerator, hence it's a to the power m. Next, law number 8. What if the power is a fraction? So this is how we solve it. A to the power m over n. It can be written as n root of a, then close bracket to the power m. Or it is equals to n root a to the power m. So what is the difference between these two? So the first one is that we n root it first, then we go to the power. For the second one, we power the number first, then we n root it. Alright, so these are the 8 laws of indices that you need to remember. Now let's discuss about grouping laws. The first 2 laws of grouping laws are: number 1, a to the power m times a to the power n equals a to the power m plus n. Number 2, a to the power m divided by a to the power n equals a to the power m minus n. As discussed previously, there is one thing in common between these 2 laws, which is they have the same body. Hence, for multiplication, we can add the power, and for division, we can subtract the power. Now, you may wonder, why is this so? Let's look at this example. Number 1, 2 to the power 5 times 2 to the power 3. We know that 2 to the power 5, it means that the 2 multiply itself for 5 times. Similarly, for 2 cubed, we know that the 2 multiply itself for 3 times. Hence, from here, when they multiply together, we can see that in total, 2 multiply itself for 8 times. Hence, it becomes 2 to the power 8. And you can see that the 8 here, we can also add these 2 powers together. 5 times 3 equals to 8. Similarly, example number 2 here, 2 to the power 5 divided by 2 cubed. Again, we know that 2 power 5 means that the 2 multiply itself for 5 times, and 2 cubed, the 2 multiply itself for 3 times. And from here, we can cancel the 2 one by one. The top cancel with the bottom, the top cancel with the bottom, and we have 2 2's here, which means that it is 2 squared. And from here, we can see that when it comes to division, we can take the first power minus with the second power. So 5 minus 3, we get 2 here. Hence, this makes these 2 laws sense. Now, let's look at some examples on the first 2 laws of grouping laws. Here is the example. Simplify the following. A, x to the power 4 times x to the power 8. And B, bracket s 4s cubed t times bracket 5s squared t to the power 4. So here is a solution. For A, x to the power 4 times 8 x to the power 8. You can see the same body, hence we can add the power, so it is x to the power 4 plus 8, and the answer is x to the power 12. For b, bracket 4s cubed t times bracket 5s squared t to the power 4. So from here, what we can do is we can group the similar number together. So which is 4 times 5, then bracket s cubed times s squared, bracket t times t to the power 4. So 4 times 5 is 20, and for the s is s to the power 3 plus 2, and for the t is t to the power 1 plus 4. And the answer is 20 s to the power 5 t to the power 5. Now, you can try this example yourself. Simplify the following. A. X to the power 9 times x to the power 7. B. Bracket 3p cubed q squared times bracket 8q to the power 5 p to the power 6. You can pause the video and try to do it yourself. Okay, here is the solution. For A, x to the power 9 times x to the power 7. So we have the same body here, which is x. Hence, we can add the power, which is x to the power 9 plus 7. And we get the answer, x to the power 16. For B, bracket 3p cubed q squared times bracket 8q to the power 5 p to the power 6. Again, we can group the like numbers together, which is bracket 3 times 8, bracket p cubed times p to the power 6, bracket q squared times q to the power 5. So 3 times 8 we get 24, and p to the power 3 plus 6, q to the power 2 plus 5. And the answer is 24 p to the power 9 q to the power 7. Here is another example which is related to the second law. Simplify the following. A. Y to the power 6 divided by y squared. B. Bracket negative 12 m to the power 5 n cubed divided by bracket 4m cubed n squared. Here is a solution for A. Y to the power 6 divided by y squared. So we can see that they have the same body, so we can subtract the power, which is y to the power 6 minus 2, and we get y to the power 4. For B, bracket negative 12m to the power 5 n cubed divided by bracket 4m cubed t squared. So we can group the like terms or like numbers together. For this case, it's negative 12 over 4, bracket m to the power 5 over m cubed, bracket n cubed over n squared. So n 12 divided by 4 we get negative 3, m 5 minus 3, and n 3 minus 2. The answer is negative 3 m squared n. Now you can try this similar example yourself. Simplify the following. A. K to the power 12 divided by k to the power 9. B. Bracket 75 c to the power 7 d to the power 8 divided by bracket 5c to the power 5 d to the power 6. You can pause the video and try to solve it yourself. Alright, here's the solution. For A, k to the power 12 divided by k to the power 9, they have the same body and it is division, so we can say that it is equals to k to the power 12 minus 9, and the answer is k cubed. For B, bracket 75 c to the power 7 d to the power 8 divided by bracket 5 c to the power 5 d to the power 6. So we can group the like numbers together, which is bracket 75 over 5, bracket c power 7
over c to the power 5 bracket d to the power 8 over d to the power 6. So 75 divided by 5 you get 15, then c to the power of 7 minus 5, d to the power of 8 minus 6, and the answer is 15 c squared q squared. Now let's see example that mix up the first two laws. So simplify the following. A. 6 to the power 7 times 6 to the power 9 divided by 6 to the power 12. B. 2 to the power 12 times 2 to the power 4 divided by 4 cubed. Here's the solution. So you can see that these three numbers, they have the same base, which is 6. Hence, we can just write it as equals to 6 to the power 7 plus 9 minus 12, because when it is multiplied, we add the power. When it is division, then we minus the power. Alright, so the answer is 6 to the power 4. So for B, you can see that 2 to the power 12 times 2 to the power 4 divided by 4 cubed. So seems that this is not the same body 4, but don't forget that 4 is 2 squared. So it will be equals to 2 to the power 12 times 2 to the power 4 divided by bracket 2 squared close bracket cube. So now we remove the bracket, then it becomes 2 to the power 12 times 2 to the power 4 divided by 2 to the power 6, because when we remove the bracket, it is 2 times 3. Then from here, when it is multiplied, we add the power. When it is divide, we minus the power. So it becomes 2 to the power 12 plus 4 minus 6, and we get 2 to the power 10. Now you can try this example yourself. Simplify the following. A. 5 to the power 6 times 5 to the power 8 divided by 5 to the power 10. B. 3 to the power 8 times 3 to the power 9 divided by bracket 81 cube. You can pause the video and try to solve it yourself. Alright, here is the solution. For A, 5 to the power 6 times 5 to the power 8 divided by 5 to the power 10. So again, they have the same body. When you see the multiplication, we add the power. When we see the division, then we minus the power. So it becomes 5 to the power 6 plus 8 minus 10. And the answer is 5 to the power 4. For B, 3 to the power 8 times 3 to the power 9 divided by bracket 81 cube. So again, we see that it seems that 81 is not the same body, but don't forget 81 is 3 to the power 4. So we get 3 to the power 8 times 3 to the power 9 divided by bracket 3 to the power 4 close bracket cube. And now we want to remove the bracket. So when you remove the bracket, we multiply the power. 4 times 3, which is 12. So it becomes 3 to the power 8 times 3 to the power 9 divided by 3 to the power 12. So again, we see the multiplication, we add the power. If we see the division, then we minus the power. So it becomes 3 to the power 8 plus 9 minus 12. And the answer is 3 to the power 5. Now, let's discuss the next two laws in grouping laws, which is law number 3, a to the power m times b to the power m equals bracket a times b close bracket to the power m. Law number 4, a to the power m divided by b to the power m, or we can write it in fraction, which is a to the power m over b to the power m equals bracket a over b close bracket to the power m. As discussed previously, there is one thing in common in these two laws, which is they have the same power. Let's see these examples to verify these two laws. Number 1, 2 cubed times 5 cubed. We know that 2 cubed means the 2 multiply itself for 3 times, and 5 cubed means the 5 multiply itself for 5 times. We can rearrange this equation and pair the 2 and 5 together, and it becomes 2 times 5 times 2 times 5 times 2 times 5. Notice that 2 times 5 multiply itself for 3 times. Hence, we can write 2 times 5 cubed. So this verify the law number 3. Next, 2 cubed divided by 5 cubed. We can rewrite it as a fraction, which is 2 times 2 times 2 over 5 times 5 times 5. And now we can break it into 3 fractions, which is 2 over 5 times 2 over 5 times 2 over 5. And it is also equals bracket 2 over 5 close bracket cube. Hence this verify law number 4. Notice that these two laws are reversible, which is bracket AB close bracket to the power m equals a to the power m times b to the power m. Bracket a over b close bracket to the power m equals a to the power m over b to the power m. These two equations are more commonly used, especially when we want to remove the brackets. Bracket law, which is law number 5. Bracket a to the power m close bracket to the power n equals a to the power m times n. We can use this law to remove the bracket where the power can multiply together. So let's see this example to verify this law. We have bracket 2 cubed close bracket to the power 4. We know that 2 cubed means 2 multiply itself for 3 times, and outside the bracket is to the power 4. So which means that the bracket multiply itself for 4 times. So from here, this is what we get. And we can count how many times the 2 multiply itself. So we have 4 brackets, and every bracket 2 multiply itself for 3 times. Hence it is 2 to the power of 3 times 4, which is 2 to the power of 12. Hence this verify law number 5. Now let's discuss examples related to grouping and bracket laws. Here is an example. Simplify the following. A. Bracket x cubed close bracket to the power 4. B. Bracket p squared close bracket cube divided by bracket p to the power 4 close bracket to the power 5. Here is the solution. For A, bracket x cubed close bracket to the power 4 equals, we can remove the bracket and multiply the power together, which we get x to the power 3 times 4, and the result is x to the power 12. For B, bracket p squared close bracket cube divided by bracket p to the power 4 close bracket to the power 5. We can remove the bracket one by one, and we can multiply the power together. So we will get p to the power 2 times 3 divided by p to the power 4 times 5. We get p to the power 6 divided by p to the power 20. And we know that if it is division, we have the same body, we can minus the power, which we get p to the power 6 minus 20. We get p to the power negative 14, and we want to make the power to be positive, hence it is equals 1 over p to the power 14. Now you can try this simpler example yourself. Simplify the following: a bracket k to the power 6 close bracket to the power 7, b bracket a square close bracket to the power 4 divided by bracket a cube close bracket to the power 5. You can pause the video and try to do it yourself. Alright, here's the solution. For a bracket k to the power 6 close bracket to the power 7 equals k to the power 6 times 7, and we get the result k to the power 42. For b bracket a square close bracket to the power 4 divided by bracket a cube close bracket to the power 5 equals a to the power 2 times 4 divided by a cube times 5. We get a to the power 8 divided by a to the power 15. Next, it will be equal a to the power 8 minus 15. Result is a to the power negative 7, or 1 over a to the power 7. Now, let's see more complicated example. Simplify the following: a bracket 3p square q cube close bracket to the power 4 times bracket 2p to the power 5 q to the power 6 close bracket square. b bracket 2a square over b close bracket cube divided by bracket negative a to the power 5 over b cube close bracket to the power 8. Here's the solution. For a bracket 3p square q cube close bracket to the power 4 times bracket 2p to the power 5 q to the power 6 close bracket square, we can remove the bracket first. So now it becomes 3 bracket 3 to the power 4 times p to the power 2 times 4 times q to the power 3 times 4 close bracket times open bracket 2 square times p to the power 5 times 2 times q to the power 6 times 2 close bracket. We simplify and get bracket 81 times p to the power 8 q to the power 12 close bracket times open bracket 4 times p to the power 10 q to the power 12 close bracket. So now number multiplied with number, so 81 times 4, and the variable multiply group with the variable, so becomes p to the power 8 plus 10 q to the power 12 plus 12, and the answer is 324 p to the power 18 q to the power 24. For b bracket 2a square over b close bracket to the power 3 divided by bracket negative a to the power 5 over b cube close bracket to the power 8. So again, the first thing we can do is remove the bracket, but this round need to be careful with the negative sign. So for the first bracket, we get 2 cube times a to the power 2 times 3 over b cube divided by open bracket. Now for here, the negative sign we can treat it as negative 1. So it is bracket negative 1 close bracket to the power 8, times a to the power 5 times 8 over b to the power 3 times 8, close bracket. So we simplify, it becomes 8a to the power 6 over b cubed divided by bracket. Now negative 1 to the power 8, we get positive 1. Okay, times a to the power 40 over b to the power 24, close bracket. So this is what we get after removing the 1, which is 8a to the power 6 over b to the power 3 divided by a to the power 40 over b to the power 24. Next, we change the division sign to multiplication sign. We get 8a to the power 6 over b cubed times b to the power 24 over a to the power 40. Now we group the like variable together, which is 8a to the power 6 minus 40 b to the power 24 minus 3. We get 8a to the power negative 34 b to the power 21. And we want to leave our answer as positive indices, hence the answer is 8b to the power 21 over a to the power 34. Now you can try this example yourself. Simplify the following. A bracket 4x squared y to the power 6 close bracket cube times bracket 5x to the power 4 y to the power 5 close bracket to the power 4. B bracket 5p to the power 7 over q to the power 4 close bracket to the power 5 divided by bracket negative 5p to the power 5 over q to the power 6 close bracket cube. You can pause the video and try to solve it yourself. Here is the solution. For A, bracket 4x squared y to the power 6 close bracket cube times 5x to the power 4 y to the power 5 close bracket to the power 4. We can remove the bracket, so we get 4 bracket 4 cube times x to the power 2 times 3 y to the power 6 times 3 close bracket times bracket 5 to the power 4 times x to the power 4 times 4 y to the power 5 times 4 close bracket. So we get bracket 64 times x to the power 6 y to the power 18 close bracket times bracket 625 times x to the power 16 y to the power 20 close bracket. So next one, numbers multiplied with numbers, variable combined with variable. So we get 64 times 625 times x to the power 6 plus 16 y to the power 18 plus 20. And the answer is 40,000 x to the power 22 y to the power 38. For B, bracket 5p to the power 7 over q to the power 4 close bracket to the power 5 divided by bracket negative 5p to the power 5 over q to the power 6 close bracket cube. So the first thing we can do is remove the bracket. We get 5 to the power 5 p to the power 7 times 5 over q to the power 4 times 5 divided by, and here the negative sign we can combine with the 5, which we get negative 5 cube times p to the power 3 times 5 over q to the power 6 times 3. Simplify, we get 3125 p to the power 35 over q to the power 20 divided by bracket negative 125 times p to the power 15 over q to the power 18. Next, we change the division sign to multiplication sign. we get 3125 p to the power 35 over q to the power 20 times bracket q to the power 18 over negative 125 times p to the power 15 close bracket. So number divided with the number, variable group with variable. So we get 3125 over negative 125 p to the power 35 minus 15 q to the power 18 minus 20. We get negative 25 p to the power 20 q to the power negative 2. And we want to leave our answer in positive indices. We get negative 25 p to the power 20 over q squared. Next, we will discuss zero indices, which is law number 6, a to the power 0 equals to 1. Let's verify this law. By indices law, we have a to the power m divided by a to the power m equals a to the power m minus m, and we get a to the power 0. By calculation, a to the power m divided by a to the power m equals a to the power m over a to the power m. And since the numerator is the same value as the denominator, we get 1. Hence, from here, we can say that a to the power 0 equals to 1, which verify this law. Next, negative indices, which is law number 7. A to the power negative m equals 1 over a to the power n. Let's verify this law. By indices law, a to the power m divided by a to the power negative 2m equals a to the power m minus 2m, because they have the same body, and the result is a to the power negative m. By calculation, a to the power m divided by a to the power 2m, we can rewrite it to be a to the power m divided by a to the power 2m. And the a to the power 2m is bracket a to the power m close bracket square. So, which means that it is a to the power m over a to the power m times a to the power m. When we simplify, we get 1 over a to the power of m. Hence, we can make the conclusion that a to the power negative m equals 1 over a to the power m. Therefore, this verifies law number 7. Take note that a cannot be 0, because 0 to the power 0, 0 to the power negative 1, 0 to the power negative 2, and so on, equals 0 to the power 0 over 0 to the power 0, 1 over 0, 1 over 0 square, and so on. Any number divided by 0 that is undefined. Now, let's see some examples related to zero and negative laws. Simplify the following. A. 3 to the power negative 3 plus 7 to the power 0. B. 9 cubed divided by 9 to the power 6. C. Bracket 2 to the power negative 3 close bracket to the power 4 times bracket 2 to the power 5 close bracket square. D. Bracket 3 over 7 close bracket to the power negative 3. Here is the solution. For A, 3 to the power negative 3 plus 7 to the power 0, it is equals to 1 over 3 cubed plus 1. So 3 cubed is 27, and we get 1 over 27 plus 1, and the answer is 1 and 1 over 27. For B, 9 cubed divided by 9 to the power 6. So both have the same body and it is division. We can write it as 9 to the power 3 minus 6, which is 9 to the power negative 3, and we want to leave our answer to be positive indices. It is 1 over 9 cubed, and the answer is 1 over 729. For C, bracket 2 to the power negative 3 close bracket to the power 4 times bracket 2 to the power 5 close bracket square. We want to remove the bracket. We get 2 to the power negative 3 times 4 times 2 to the power 5 times 2. And we get 2 to the power negative 12 times 2 to the power 10. So same body, involve multiplication. We get 2 to the power negative 12 plus 10. And we get 2 to the power negative 2. We want to leave our answer in positive indices. So we can write it as 1 over 2 square. And the answer is 1 over 4. For D, bracket 3 over 7 close bracket to the power negative 3. So we can change the negative power to become positive power, which we get 1 over bracket 3 over 7 close bracket cube. To make our calculation easier, we can write it as 1 divided by bracket 3 over 7 close bracket cube. Now we remove the bracket, we get 1 divided by 3 cube over 7 cube. Next, we change the division sign to become multiplication sign. We get 1 times 7 cube over 3 cube. So the answer is 343 over 27. From here, take note that we can do a shortcut, which is bracket a over b close bracket to the power negative m equals b over a close bracket to the power n. Hence, we actually don't have to write that many steps. We can actually change from here to here. Now you can try this similar example yourself. Simplify the following. A. 5 to the power negative 2 minus 4 to the power 0. B. 7 cubed divided by 7 to the power 5. C. Bracket 6 to the power 5 close bracket square times bracket 6 cubed close bracket to the power negative 4. D. Bracket 3 over 5 close bracket to the power negative 4. You can pause the video and try to solve it yourself. Alright, here's the solution. For A, 5 to the power negative 2 minus 4 to the power 0. So the negative power, we want to change to positive. We get 1 over 5 square. And 4 power 0 is 1. So it is 1 over 5 square minus 1. Which is 1 over 25 minus 1. And the result is negative 24 over 25. For B, 7 cubed divided by 7 to the power 5. So since both have the same body, operation is division, so it is equals 7 to the power 3 minus 5, which is 7 to the power negative 2. So change to positive indices, we get 1 over 7 square, and the answer is 1 over 49. For C, bracket 6 to the power 5 close bracket square times bracket 6 cubed close bracket to the power negative 4. So I want to remove the bracket, we get 6 to the power 5 times 2 times 6 to the power 3 times negative 4. And we get 6 to the power 10 times 6 to the power of negative 12. So since both have the same body and the operation is multiplication, we can write it as 6 to the power 10 plus negative 12. We get 6 to the power negative 2, which is 1 over 6 square, and the answer is 1 over 36. For D, bracket 3 over 5 close bracket to the power of negative 4. So the first thing we want to do is change the indices to become positive. Then the fraction, we have to swap the position. The numerator becomes denominator and the denominator becomes numerator. So we get bracket 5 over 3 close bracket to the power of 4. Next, remove the bracket, we get 5 to the power of 4 over 3 to the power of 4. So the answer is 625 over 81. Let's see more examples related to zero and negative laws. Here's an example. Simplify the following and express your answers in positive index notation. A. Bracket x to the power of negative 2 y cubed close bracket to the power of negative 4. B. Bracket a to the power of 4 b to the power of negative 5 close bracket a to the power of negative 3 b to the power of 5 close bracket. And C. Bracket 21 r to the power of 8 s to the power of negative 5 close bracket divided by bracket 3r to the power of negative 3 s to the power of negative 2 close bracket. Here's the solution. For A, bracket x to the power of negative 2 y cubed close bracket to the power of negative 4, we can distribute the power negative 4 to each element, which becomes bracket x to the power of negative 2 close bracket to the power of negative 4 bracket y cubed close bracket to the power of negative 4. Then we remove the bracket by multiplying the power, so we get x to the power of negative 2 times negative 4 y to the power of 3 times negative 4. We get x to the power of 8 y to the power of negative 12. And since we want to leave the answer in positive index notation, hence the answer will be x to the power of 8 over y to the power of 12. For B, bracket a to the power of 4 b to the power of negative 5 close bracket a to the power of negative 3 b to the power of 5 close bracket. So this is a multiplication, hence for the same body we can add the power together, so we get a to the power of 4 plus negative 3 times b to the power of negative 5 plus 5, and we get a to the power of 1 b to the power of 0, since b to the power of 0 is 1 and a to the power of 1 is still a, so the answer is A. For C, bracket 31r to the power of 8 s to the power of negative 5 close bracket divided by bracket 3r to the power of negative 3 s to the power of negative 2 close bracket. So we can rewrite it in fractions, which we get 21r to the power of 8x to the power of negative 5 over 3r to the power of negative 3 s to the power of negative 2. Then 31 divided by 3 we get 7. So this is a division, so the r will be to the power of 8 minus negative 3 and s will be to the power of negative 5 minus negative 2. We get 7r to the power of 11 s to the power of negative 3. So leave the answer in positive index notation, we get 7r to the power of 11 over s cubed. Now you can try this similar example yourself. Simplify the following and express your answers in positive index notation. A, bracket a to the power of negative 4 b cubed close bracket to the power of negative 4. B, e to the power of 6 f to the power of negative 2 times e to the power of negative 6 f to the power of negative 3. C, 4k to the power of negative 3 r to to the power 8 divided by 64k to the power 4 r to the power 6. You can pause the video and try to solve it yourself. So here's the solution. A bracket a to the power negative 4 b cubed close bracket to the power negative 4. We can expand and we get a to the power negative 4 times 4 b to the power 3 times negative 4, and we get a to the power 16 b to the power negative 12. Since we want to leave the answer in positive index notation, we can rewrite it as a to the power 16 over b to the power 12. For b, bracket e to the power 6 f to the power negative 2 times e to the power negative 6 f to the power negative 3. So this is a multiplication. Same body, we will add the power. So e to the power 6 plus negative 6 f to the power negative 2 plus negative 3. We get e to the power 0 f to the power negative 5. So e to the power 0 is 1, and want to change the answer in positive index notation, we get 1 over f to the power 5. C. 4k to the power negative 3 r to the power 8 divided by 64 k to the power 4 r to the power 6. So change it into fraction, we get 4k to the power negative 3 r to the power 8 over 64 k to the power 4 r to the power 6. Okay, so number divided with the number, so 4 over 64, and this is an division, so k to the power negative 3 minus 4 and r to the power 8 minus 6. We get 1 over 16 k to the power negative 7 r squared. And to leave the answer in positive index notation, we get r squared over 16 k to the power 7. The last law in the laws of indices is fractional indices, which is law number 8. A to the power m over n equals bracket n root of a to the power m, or also equal n root of a to the power m. Let's verify this law. From grouping law, we know that a to the power half times a to the power half equals a to the power half plus half. So from the left hand side, we can see that a to the power half multiplies itself for 2 times. Hence, we can write it as a to the power half squared. And the right side is a to the power 1, which is a. So from here, we square root both sides. We get a to the power half equals square root of a. Similarly, a to the power 1/3 times a to the power 1/3 times a to the power 1/3 equals a to the power 1/3 plus 1/3 plus 1/3. So from the left hand side, we can see that a to the power 1/3 multiplies itself for 3 times. Hence, we can write it as bracket a to the power 1/3 close bracket cube equals the right side is a to the power 1, which is a. Then we cube root both sides, and we get a to the power 1/3 equals cube root of a. So from here, we can make it to be more generic, which we get a to the power 1 and 1 over n equals n root of a. Also, we can apply bracket law. For a to the power m over n, it is equal to a to the power 1 over n close bracket to the power m. Or it is also a to the power m over n equals bracket a to the power m close bracket to the power 1 over n. So we change the 1 over n to be n roots. So we get a to the power m over n equals bracket n root of a close bracket to the power m or a to the power mon equals n root of a to the power m. Hence, we verify law number 8. Now, let's see one example related to fractional indices. Evaluate the following without using a calculator. A. 32 to the power of 2/5 and B. 81 to the power of -3/4. Here is a solution. For A. 32 to the power of 2/5, there are actually at least 3 ways to get the answer. Here is one other way, which is equals to root 5 of 32 square. So root 5 of 32 we get 2, hence 2 square equals 4. Or we can also say that 32 to the power of 2/5 equals root 5 of 32 square, which we get root 5 of 1024, and the answer is 4. Or 32 to the power of 2/5 equals bracket 2 to the power of 5 close bracket to the power of 2/5. By applying bracket law, we get 2 to the power of 5 times 2/5, which is 2 square, and the answer is 4. In the exam, unless otherwise stated, you can use any of the method here to get the answer. However, for the next example, we will just stick to fractional indices as this is the topic that we are discussing now. So let's look at B. 81 to the power of -3/4 we can equals to 4 root 4 of 81 to the power of -3. So root 4 of 81 is 3, then to the power of -3, which is 1/27. Okay, you might also ask if we can use this method. Yes, you still can use this method. However, I will prefer and suggest you to use the first method, which means we root first, then we power it. The reason is because we'll make the number smaller and it is easier for our calculation. For the second method, if you notice, when we power the number, we get a bigger number, and it is more difficult for us to calculate and get the answer. Now you can try this example yourself. Evaluate the following without using a calculator. A. 25 to the power of 3/2. B. 16 to the power of -5/4. You can pause the video and try to solve it yourself. Alright, here's the solution. For A, 25 to the power of 3/2 equals square root of 25 cubed. So square root of 25 is 5. So 5 cubed is 125. For B, 16 to the power of -5/4, which is equals to root 4 of 16 to the power of -5. So root 4 of 16 is 2, so 2 to the power of -5, and the answer is 1/32. Now, let's see another example related to fractional indices. This time, we want to involve unknowns. Simplify the following. Leave your answers in positive index notation. A. Bracket x to the power of 2/3 close bracket to the power of 7 times x to the power of 1/3. B. b bracket a to the power negative 3 over 4 b to the power of 2 over 5 close bracket divided by bracket a square b to the power negative 3. Here is the solution. For a, bracket x to the power 2/3 to the power 7 times x to the power 1/3. The first step we do is we apply bracket law, which we get x to the power 2/3 times 7 times x to the power 1/3. Hence we get x to the power 14 over 3 times x to the power 1/3. Since both have the same body, we can add the power together. So it's x to the power 14 over 3 plus 1 over 3, which is x to the power 15 over 3. We can simplify and get x to the power 5. For b, bracket a to the power negative 3 over 4 b to the power 2 over 5 divided by bracket a square b to the power negative 3. So since it is a division, and we can see that there are some bodies the same, like a and the b, so we can minus the power, which we get a to the power negative 3 over 4 minus 2 b to the power 2 over 5 minus negative 3, and we get a to the power negative 11 over 4 b to the power 17 over 5. Since the question asks us to leave answers in positive index notation, the answer is b to the power 17 over 5 over a to the power 11 over 4.
Alright, now it's your turn to try this similar example yourself. Simplify the following. Leave your answers in positive index notation. A, bracket a square, close bracket, to the power 5 over 6 times a to the power 2/3. B, bracket s to the power 5 over 4 t to the power negative 7 over 4, close bracket, divided by s to the power 3 over 2 t to the power negative 5 over 2. You can pause the video and try to solve it yourself. Alright, here is the solution. For a, bracket a square, close bracket, to the power 5 over 6 times a to the power 2/3. So you can see that the first a we have bracket, so we can apply the bracket law to remove the bracket, which we can multiply the power. So we get a to the power 2 times 5 over 6 times a to the power 2/3. So we calculate the power, we get a to the power 5 over 3 times a to the power 2/3. Here we can see that both have the same body and it is multiplication. So if we can add the power together, which we get a to the power 5 over 3 plus 2 over 3. And the answer is a to the power 7 over 3. For b, bracket s to the power 5 over 4 t to the power negative 7 over 4, close bracket, divided by s to the power 3 over 2 t to the power negative 5 over 2. So we can see that this is a division, right? So we can same body, so division, that means that we can minus the power. So for the s, we have s to the power 5 over 4 minus 3 over 2 times t to the power negative 7 over 4 minus negative 5 over 2. So now we can do the calculation. We get s to the power negative 1 over 4 t to the power 3 over 4. So since we need to leave the answer in positive index notation, then we can rewrite this answer to be t to the power 3 over 4 over s to the power 1 over 4. So you can, from here you can also write the answer as bracket t cubed over s close bracket to the power 1 over 4.
We have discussed all the indices laws in detail. Now, let's see examples that combine all indices laws. Here is one example. Simplify the following expressions. A, bracket x to the power 4 y to the power negative 2 over x to the power negative 4 y cubed, close bracket, times bracket x to the power negative 3 y to the power 4 over x to the power negative 1 y to the power 5 close bracket to the power of negative 2. For b, bracket pq cube close bracket to the power of negative 5 bracket 3 p to the power 4 q to the power of negative 4 close bracket to the power of negative 3 over bracket 6 pqr close bracket cube bracket 9 pr square close bracket to the power of negative 2. So look at these examples. The expressions are complicated. So here is a solution. There are many ways you can get the answer depending on which laws you want to use first. So let's look at A. Bracket x to the power 5 y to the power negative 2 over x to the power negative 4 y cube close bracket times bracket x to the power negative 3 y to the power 4 over x to the power negative 1 y to the power 5 close bracket to the power negative 2. So I would suggest that we simplify bracket by bracket first. So for the first bracket, we can see that it is a division, so we can minus the power. So similarly for the second bracket, we do the similar thing, is a division, and the power we can minus for the same body. Right? So now let's look at the first bracket. It will be bracket x to the power 5 minus negative 4 y to the power negative 2 minus 3. For the second bracket, it is x to the power negative 3 minus negative 1 y to the power 4 minus 5, then close bracket to the power negative 2. So simplify the power, we get the first bracket is x to the power 9 y to the power negative 5, then second bracket is x to the power negative 2 y to the power negative 1 close bracket to the power negative 2. Okay, so now we look at the second bracket. We want to use the bracket law to remove the power outside. For the first bracket, we don't do anything, so we just copy it out. Hence we get bracket x power 9 y to the power negative 5 close bracket times bracket x to the power negative 2 times negative 2 y to the power negative 1 times negative 2. So we get bracket x to the power 9 y to the power negative 5 close bracket x to the power 4 y square close bracket. So it is a multiplication, hence we can add the power together for the same body. So for the x is x to the power 9 plus 4, and for the y is y to the power negative 5 plus 2. We get x to the power 13, y to the power negative 3. And we want to put the power to be positive power, we will get x to the power 13 over y cubed. For b, bracket pq cube close bracket to the power negative 5 bracket 3p to the power 4 q to the power negative 4 close bracket to the power negative 3 over bracket 6pqr close bracket cube bracket 9pr square close bracket to the power negative 2. So for this case, you can see that all the brackets contain one power outside. So we have to apply the bracket law to remove the power outside the bracket. Hence, for the first bracket, it is p to the power negative 5, q to the power negative 15, and second bracket is 3 to the power negative 3, p to the power negative 12, q to the power 12. Look at the denominator. For the first bracket is 6 cube, p cube, q cube, r cube, and for the second bracket, it is 9 to the power negative 2, p to the power negative 2, r to the power negative 4. Okay, the next step is very critical. So what we can do is we can combine the numbers together and the variables combined separately. So we get, for the first bracket, it is the numbers. It will be 3 to the power negative 3 over 6 cubed times 9 to the power negative 2. For the second bracket is combining the p, we get p to the power negative 5 plus bracket negative 2 minus 3 minus negative 2. For the q, it is q to the power negative 15 plus 12 minus 3. For the r, it is 1 over r to the power of negative 4. Okay, so simplify the number, we get 9 square over 6 cube times 3 cube, where we actually put the power to be positive power first. For the p, it is p to the power of negative 18, q to the power of negative 6, r to the power of 4. And the number, just press calculator, the value is 1 over 72. For p and q, we put the power to be positive power, we get 1 over p to the power of 18, 1 over q to the power of 6. R remain the same, r to the power of 4. So combining everything together, we get r to the power of 4 over 72, p to the power of 18, q to the power of 6. Alright, now try this example yourself. Simplify the following expressions. A. 5x to the power 4 y to the power 5 over 6x cubed y squared times bracket 25x squared y cubed close bracket to the power of negative 2 over 36xy close bracket to the power of negative half. For b, bracket pq squared close bracket to the power of negative 3 divided by bracket p cubed q to the power 4 close bracket to the power of negative 2/3 over bracket 3pq close bracket to the power of negative 1 bracket 9 p to the power of negative 2 q to the power of negative 3 close bracket q to the power of negative 1. You can pause the video and try to do it yourself. Alright, here is the solution for A. So notice this expression, there are two fractions. This is the first fraction and this is the second fraction. So there are many ways we can simplify it. The objective is we want to make our simplification easy. So what we can do is, we can simplify fraction by fraction. So the first step is we simplify the first bracket. Notice that this is the number, so we group with the number, so 5 by 6, and for the x is a division, same for the y, right? So for division, the power will be minus, so it's x to the power 4 minus 3, but the y is y to the power 5 minus 2. Okay, now look at the second fraction. Both have brackets and the power is negative, so we change the power to be positive by switching the positions. So we get times bracket 36xy to the power of half over bracket 25x squared y cubed then square. Alright, so the next step, after we simplify the first bracket, we get 5 by 6 xy cubed. For the second fraction, we get times with 36 to the power half, so we apply the bracket law, we get 36 to the power half x to the power of half y to the power half over, so over here 35 square we get 635 x square times x square and square, we get x to the power 4, so y to the power 6 because 3 times 2 we get 6. Right, now over here we can group the number together, x and y, we group them separately. Okay, so we get 5 times 6 over 6 times 625 times x to the power of, so over here this is power 1 plus half minus 4. Okay, so x to the power 1 plus half minus 4. For the y, here is 3, right? So 3 plus half minus 6. Okay, so next step, we simplify further, we get 1 over 1 to 5 x to the power of negative 5 over 2 y to the power of negative 5 over 2. Alright, so once get the answer, since this is a negative power, we have to change them to positive power, so we get 1 by 125 x to the power 5 by 2 y to the power 5 by 2. Okay, so the power is positive and this is the final answer. Okay, now next step, next one, b. So we can see that this is a whole huge fraction here, right? And there are many brackets. There's a division here. Most of the powers are negative powers, right? Negative 3, negative 2/3, negative 1. So this negative 2, negative 3, and negative 1. Okay, so we want to make the power to be positive, but be careful with the 9. The power of 9 is actually positive 1. Okay, so we want to make the power to be positive, we have to change their position. Okay, except for 9, and be careful with the division here also. So what we do is, for all this, change to positive power. So 3pq power negative 1 becomes 3pq, move it to the top, right? Similarly, 9 here, p negative 2, q negative 3, we get p squared q cube. Move these two to the top, and q negative 1 becomes q here, right? So the 9 still remain at the bottom, and this one, p bracket p q squared negative power negative 3, we move to the bottom, becomes bracket p q squared close bracket q. So over here, the next one, division change to multiplication, so becomes 1 over bracket p cube q to the power 4 close bracket to the power of negative 2/3. Okay, notice that the power is still negative. We haven't changed the power yet because we only changed the sign. Division becomes multiplication. Alright, now the next step is we can start to group. Right, the top here with p squared, so becomes p cube. So 1, but the power is 1 here, 1 plus 2 becomes 3 p cube. So the 3 cancel with the 9, so only with 3 at the bottom. Q here, q power 1, q cube, and another q here, so 3 plus 1 plus 1, so we get q to the power 5. Right, and at the bottom here, we remove the bracket by applying bracket law, we get p cube q to the power 6. Okay, and here, right, since this is a negative power, we change to positive power, it becomes bracket p cube q to the power 4 close bracket to the power 2/3. Okay, now further simplify, right? So we, for this here, p cube and p cube cancelled, so q to the power 5 divided by q to the power 6, we get the q at the bottom, q power 1, right? And for this part, bracket, we remove the bracket again by applying bracket law, so we get p squared q to the power 8 over 3, because 3 times 2/3 we get 2, 4 times 2/3 we get 8 over 3. Okay, and the next step is, since we still have the q at the top and the bottom, so we minus, it is 8 by 3 minus 1. Okay, we get p squared q to the power 5 by 3 over 3, and this is the final answer. Do you get the answer correctly? Alright, the last part of this chapter is solving equations involving indices. To solve equations involving indices, we use the following properties. If a to the power m equals to a to the power n, where a is greater than 0 and a is not equals to 1, then we can say that m equals to n, where we are comparing the power if the body for left hand side and right hand side is equal. Do take note that if a to the power m equals to 1, it also can be written as a to the power m equals to a to the power 0, hence m equals to 0. Now, let's take a look of this example. Solve the following equations. A, 3 to the power x equals to 243. B, 64 to the power 2x minus 3 equals to 1 over 4. here is the solution. For a, 3 to the power x equals to 243. We know that 243 is 3 to the power 5. Therefore, 3 to the power x equals to 3 to the power 5. So, for this case, the left hand side and the right hand side have the same body, which is 3. Hence, we can compare the power and we can say that x equals to 5. For b, 64 to the power of 2x minus 3 equals to 1 over 4. So, from this equation, we know that 64 and 4 are multiples of 2. So, we can change the 64 to be 2 to the power of 6, and for the 4 is 2 squared. So, this equation becomes bracket 2 to the power of 6 close bracket to the power of 2x minus 3 equals to 2 to the power of negative 2, because here this is 1/4. The next step we can do is we apply the bracket law to remove the bracket here. So when we remove the bracket, the power multiply together. So 2 times 2x is 12x, 2 times 3, 6 times 3, we get 18. Okay, the right side remains the same, which is 2 to the power of negative 2. Now, both sides have the same body, which is 2. Therefore, we can compare the power, which is 12x minus 18 equals to negative 2. Then, we just solve this equation. So 12x equals to 16, because 18 minus 2 we get 16, and x equals to 4 over 3. Or now, next one, let's try this example yourself. Solve the following equations. 5 to the power x equals to 625. B, 49 to the power of 5x plus 2 equals to 1 over 343. You can pause the video and try to solve it yourself. Okay, here is the solution. For a, 5 to the power x equals to 625. We know that 625 is 5 to the power 4. So 5x equals to 5 to the power 4. Therefore, x equals to 4. For b, 49 to the power 5x plus 2 equals to 1 over 343. So we know that 49 and 343 are multiples of 7. Therefore, it is for 49, it is 7 squared. 343 is 7 cubed. So the equation becomes bracket 7 squared close bracket to the power 5x plus 2 equals to 7 to the power of negative 3. Then we apply the bracket law to remove the bracket here. We get 7 to the power of 10x plus 4, because multiply the power. So 2 times 5x is 10x, 2 times 2 is 4. The right hand side we do nothing, so just copy down. Next, since both sides have the same body, which is 7, then we can compare the power. So it is 10x plus 4 equals to negative 3. Then we solve this equation. So 10x equals to negative 7, and x is negative 7 over 10. Alright, now let's try one more example. Find the value of n for the following equations. A, t squared times square root of t over t to the power of 2/3 equals tn. B, 4 to the power n divided by 2 to the power 5 equals 64. Here is the solution. For a, t squared times square root of t over t to the power of 2/3 equals t to the power n. So we look at the left hand side, we have the square root. So what we can do is we can just change to indices, right, which is t squared, t to the power of half. So the equation becomes t squared times t to the power of half over t to the power of 2/3 equals tn. Okay, the next step, so we have multiplying here and division. So multiply, power add together, division we minus. So the equation becomes t squared plus half minus 2/3 equals t to the power n. Alright, then we can do calculate for this becomes t to the power of 11 over 6 equals t to the power n. Okay, so both sides have the same body, which is t, therefore n equals 7 over 6. Or we can change to proper fraction, which is equal 1 and 5 over 6. For b, 4 to the power n divided by 2 to the power 5 equals 64. So we can see that 4 and 64, they are multiples of 2. Therefore, 4 is 2 square, 64 is 2 to the power 6. Then the equation becomes bracket 2 square close bracket to the power n divided by 2 to the power 5 equals 2 to the power 6. Then the next step is apply the bracket law, remove the bracket. We can multiply the power, we get 2 to the power 2n divided by 2 to the power 5 equals 2 to the power 6. And here, this is a division, so we can group them together, becomes 2 to the power 2n minus 5 equals 2 to the power 6. And here, both sides have the same body, which is 2. So we can compare the power, we can say that 2n minus 5 equals to 6. Then we just solve this equation, 2n equals 11 because 6 plus 5 is 11. And n equals 11 over 2. Or equals 5.5. Alright, you can try this example yourself. Find the value of k for the following equations. A to the power of k times a to the power of 5 over 4 over cube root of a equals 1. B, 81 to the power of k divided by 27 equals 9 square. You can pause the video and try to solve it yourself. Alright, here is the solution. For a to the power of k times a to the power of 5 over 4 over cube root of a equals 1. So I hope you know what to do next. Alright, so from here we can see that this is cube root a. We can change this cube root a to indices form, which is a to the power 1/3. The next thing is here equals to 1, right? So we know that 1 is a to the power 0. Okay, so now from here we can see that all the indices here, they have the same body, right? Involve operation of multiplication and division. So for multiplication we can add the power, for division we minus the power. So this is what we get. A to the power of k plus 5 over 4 minus 1/3 equals a to the power of 0. Okay, the next step is we do the calculation here. We get a to the power of k plus 11 over 12 equals a to the power of 0. Okay, and at this level, we can see that left hand side and right hand side have the same body. Hence, we can compare the power. We get k plus 11 over 12 equals to 0. And we solve this equation, we get k equals negative 11 over 12. Okay, for b, 81 to the power of k divided by 27 equals 9 square. Okay, we look at this equation, 81, 27 and 9, they are multiples of 3. Okay, so 81 is 3 to the power of 4, 27 is 3 cube, 9 is 3 square. So the equation becomes bracket 3 to the power of 4 close bracket k divided by 3 cube equals bracket 3 square close bracket square. Okay, then we remove the bracket by applying bracket law. So the power can multiply together. We get 3 to the power of 4k divided by 3 cube equals 3 to the power of 4. Okay, now division here, same body, so we can minus the power. We get 3 to the power of 4k minus 3 equals 3 to the power of 4. Okay, and we have the same body here. We can compare the power. So 4k minus 3 equals 4. Then we solve this equation. for k equals to 7, k equals 7 over 4. Okay, we can change to proper fraction, which is 1 and 3/4. Alright, that's all for this video. Thanks for watching. Do you have any questions or thoughts to share? Feel free to write it down in the comment area. I would love to hear from you. Do you like this video? Please don't forget to like it and share it to your friends. Until then, see you in the next video. Have a great day ahead.